Let's continue with the next subtopic, which is the reaction of alcohols. Based on the structure of alcohol which contain the hydroxyl group, there are two general classes of reaction in the alcohol, which is the first reaction at the carbon of the bonding between carbon and oxygen, this one, and the second one at the proton of bonding between oxygen and hydrogen at this one. In this chapter, you will learn three reactions of alcohol. The first one is the dehydration of alcohol, which is removing of water. In this reaction, alcohol loses water, an alkene is formed, so which means from the single bond, then it will form the double bond. And then in this reaction, strong acid like sulfuric acid is used to remove water here. And of course, for this reaction, the major product will be determined based on the Set-Zeth rules. In Set-Zeth rules, it states that the major product of elimination reaction is the most stable, which highly substituted alkene. So which means you need to find which part that can be formed the highly substituted alkene in the C double bond C. We look into first example how the dehydration of alcohol can form its product. If you can see from the first compound, which is 2-methyl-2-propanol, first of all, which is first step, is you need to label the carbon which bonded with the hydroxyl group as alpha carbon, and then the adjacent carbon is the possible carbon which can form the C double bond C. So when it react with the sulfuric acid, one of the carbon can form the C double bond C. However, based on this structure, all of the adjacent carbon is the same, which is the similar structure. So then the dehydration of alcohol will produce only one product, which is you can do the C double bond C at any carbon, either carbon number 1, carbon number 2, or carbon number 3. So in this reaction, hydroxyl group will leave the alcohol group, and also one of the hydrogen from here will remove from the compound to form the side product, which is water. And then carbon alpha and carbon 1 will become double bond, so which means from single bond to double bond, and that's it. You will get the major product for the compound. Now we move to the next example. When two butanol react in dehydration reaction, it will produce two possible products. However, which one will be the major product? So first of all, you need to label the carbon that bonded with the hydroxyl group as alpha carbon, and then which means you will have two possible carbon that can be formed C double bond C, which is the first one and the second one. So based on the Set-Zeth rules, the major product is the product that which is the structure that give the highly substituted alkyl group in C double bond C, which mean this one, structure number 2. Because of what? If we expand the structure of the first structure, you will get like this structure, and then based on this structure, only one alkyl group that attach to C double bond C. If you expand the second structure, then you will get the structure like this one. So based on the second structure, you already know that there are two alkyl group that attach to the C double bond C, which will give a major product for the reaction. Next, we look into another example. When 2-methyl-2-butanol go through the dehydration reaction, it will produce two products, the first structure and the second structure. And the first structure of product is the major product and the second is the minor product. How the major product form? So if you can see here from 2-methyl-2-butanol, as I said, first of all, you need to label up the carbon that attached to the hydroxyl group as alpha carbon. So then we can have 1, 2, 3 possible products based on the structure. However, at carbon number 1 and carbon number 2 is similar structure. So we just take either one to be the product. Let's say I put the second one as the product of the reaction. So first, when the alpha carbon do the double bond with the carbon number 3, then it will be the major product because of what? If you can see the structure, at C double bond C, it attach 1, 2, and 3 alkyl group. That's why it will become the major product. Instead of when the alpha carbon do the double bond with second carbon, so then you will get the structure like this one. So from the structure at C double bond C, it only attach at 1 and 2 alkyl group. That's why the first structure is the major product. Next, we look to the last example for the following reaction. Okay, when 3-methyl-2-butanol go through the dehydration, then you will get the structure of products like this one. Okay, the first structure and the second structure. Okay, same step. Carbon that attached to the the hydroxyl group become the alpha carbon. So then based on the structure, it will have only 1 and 2 possible products. So which one will be give the major product, which is when the alpha carbon do the C double bond C with the first carbon. Okay, the first carbon. Okay, so if you can see from this structure of product at C double bond C, it attach 1, 2, 3 alkyl group instead of when alpha carbon attach at carbon number 2 or do the double bond at carbon number 2, it only have 1 alkyl group that attached to C double bond C. That's why major product is structure number 2 and minor product is structure number 1. So this is all the example of dehydration reaction. So you may try to do this exercise using and following the example that I give to you, that I explained to you. Next is the nucleophilic substitution reaction. In this reaction, alcohol react with either hydrochloric acid or hydrobromic acid. In this reaction, the hydroxyl group will be replaced by halogen. So which means, let's say if you can see from the first example, OH will replaced by the chlorine atom. So then you will get the halo alkane compound. Same as the second example, when the 2-butanol Okay, this one is 2-butanol react with HBr, then OH will leave the group, and then Br will attach to this carbon. So then you will get the product. Simple je ni. Just replace OH with the halogen atom. Okay, the halogen atom depends on which reagent that will react to the starting material. Okay, this is the nucleophilic substitution. Next is the last reaction for this chapter, which is the oxidation of alcohol. In the oxidation of alcohol, they will use either strong oxidizing agent or weak oxidizing agent. Example of strong oxidizing agents such as potassium permanganate, CrO3, or Na2Cr2O7. Meanwhile, for weak oxidizing agent, just like PCC, only PCC lah. Okay, so remember PCC, remember the weak oxidizing agent. Different oxidizing agent will give a different final product. For example, like this one. Okay, so primary alcohol, either you want to use the strong oxidizing agent or weak oxidizing agent, it will give a different products. Okay, for the oxidation of primary alcohol, if you can see the structure here, if you use mild oxidizing using the wild oxidizing agent, which is PCC, the final product is from alcohol to aldehyde. Okay, so which means alcohol will oxidize and stop at the aldehyde structure. So which means hydroxyl group will change into C double bond O H, which is this is the indication of the aldehyde functional group. Meanwhile, if you use the same alcohol but use a strong oxidizing agent, for example potassium permanganate, the alcohol will oxidize first at aldehyde and then continuously oxidize into carboxylic acid. So which means the final product for the oxidation process using the potassium permanganate is carboxylic acid. So which means OH will change into C double bond O OH, which is ini merujuk kepada carboxylic acid. For the second alcohol, either you use the potassium permanganate or PCC, the final product will always give ketone structure. So which means at hydroxyl group will change and then it will change into C double bond O. So this is the indication for the functional group for the ketone. Meanwhile, for the secondary or tertiary alcohol, when it go through the oxidation, okay, will it go through the oxidation, it will give no reaction. Okay, no reaction. So which means only primary alcohol and secondary alcohol will do the oxidation reaction. Okay, let's do the example here. So if you can see here, first of all, you need to know either the hydroxyl group attached at the intermediate, in the middle, or in the terminal, which is dekat hujung lah. So if you can see the first structure of alcohol, OH attached at terminal, which is the first carbon. Okay, the first carbon. So when it react with potassium permanganate, which is the strong oxidizing agent, as I said, alcohol will oxidize into carboxylic acid. Okay, carboxylic acid when it go through the strong oxidizing agent. So then you will get the structure or the final structure like this one. At carbon number 1, it will change into C double bond O OH. So which means OH will leave the group, and then CH2 also will leave the group, then it becomes C double bond O or H. Okay, and then for the second structure, hydroxyl group attached at in the middle of the structure, which is this is the secondary alcohol. Okay, secondary alcohol. So when the secondary alcohol react with the oxidizing agent, any oxidizing agent, it will do the oxidize, okay, from alcohol to ketone, only one product. Okay, so which means this carbon will become C double bond O. That's all. Okay, CHOH will change into C double bond O. Okay, for the third example, so in the third example, OH attached at carbon number 1, which means this is the primary alcohol, and then OH attached at the terminal. So when it reacts with the PCC, which is this is a weak oxidation process, then you will get the product of aldehyde. So then you will get the structure like this one. This carbon will become CH and C double bond O, will indicate the aldehyde structure. Next, we look into the last example. So if you can see the last example, this is the structure of tertiary alcohol. Why tertiary alcohol? So OH attached to the alpha carbon, and alpha carbon attached with 1, 2, 3 carbon, which is indicate the tertiary alcohol. When the tertiary alcohol react with the potassium permanganate, which is the oxidizing agent, it will give no reaction. Remember, I said tertiary alcohol will do not react with the oxidizing agent. Let's do the summary of the reaction of alcohol. So if you get the structure of alcohol, please identify first the classification of alcohol at the primary, secondary and tertiary. So based on the structure, the OH attached at the secondary carbon, so which means this is the secondary alcohol. So kita tengok dulu first reaction, which is the dehydration of alcohol. Dehydration of alcohol, from alcohol it will produce alkene. So this one, the structure, first of all, we label the carbon that attached to the OH as an alpha carbon. So which means it only have 1 and 2 possible products of alkene. So the first one, OH will leave the group, and then alpha carbon will do the C double bond C, either carbon number 1 and carbon number 2. Then you will get the structure, the product of structure like this one for the first one, and then the second one is like this one. Okay, alpha with first carbon, alpha with the second carbon. So which one will be the major product? Is the second structure. Because of what? Because for the second structure, if you can see here, let me change first the color. Okay, if you can see here, at C double bond C, it attach 1, 2 and 3 alkyl group. Meanwhile, for the first structure, it only have 1 alkyl group that attached to C double bond C. That's why it become the major product. And then next is the nucleophilic substitution reaction. Simple, you just replace OH with the Cl. Since it react with the HCl, so it will replace by the chlorine atom. Then you just draw the structure like this one. Okay, the same structure. Then at alpha carbon, instead of OH, you just attach with chlorine. So then you will get the final product. The last one, the oxidation of alcohol. Since this is the secondary alcohol, so when the secondary alcohol go through the oxidation, so it will form from alcohol to ketone. So just draw back the structure, okay, and then at the alpha carbon, instead of it attach COH, then it will become C double bond O, which indicate the ketone structure. So this is the product. Okay, let's say we do the structure like this one for the primary alcohol. Okay, this is the primary alcohol. The first one, dehydration. So dehydration, since it only 1, 2, 3 alpha carbon, so only possible do the double bond from between alpha and the second carbon. So then you just get the product of dehydration of alcohol like this one. Okay, the only product. And then for the nucleophilic substitution reaction, simple, just replace OH with the Cl to get the product. And then for the PCC, okay, the oxidation of alcohol, since this is the primary alcohol, either it will react with the potassium permanganate or PCC, it will give a different structure of product. First of all, when it react with the potassium permanganate, so when it react with potassium permanganate, which is strong oxidizing agent, so it will oxidize from alcohol to aldehyde and continuously to carboxylic acid. So the final product is the carboxylic acid. Then at alpha carbon, instead of it only attach at OH, it also attach C double bond O and OH. Then you will get the product. Meanwhile, when it react with the PCC, which is the weak oxidizing agent, so then it will oxidize alcohol to aldehyde only, stop at aldehyde. So the structure of product, you will get C double bond O and H. So this is the indication for the functional group of the aldehyde, C double bond O H. Okay, that's how you get the product. Okay, that's all from me for this chapter. Thank you. See you when I see you.